Okay, these ones aren't too hard. So again, to find out restrictions, you just got to look at the denominator. So let's start with the blue one. Okay, so we'll go here and there. So the secret is, again, only looking at the denominator. We've got 5t squared, and we've got a second one. So the thing you got to figure out is, if either one of these becomes 0, it will ruin the fraction. So first we look at 5t squared. That one's pretty easy. It doesn't matter if you divide the 5 out and just make it equal to 0. It doesn't matter if you divide the 5 out, it's still going to be 0, and the square root of t squared is still 0. So right away, t can't be 0. T can't be 0. Now look at the other one, t minus 5. So if t minus 5 is equal to 0, what can't t be? Well, we add 5 to this side, move to that side. T cannot be 5. So it has two restrictions. T can't be 0 and t can't be 5. If any of those cases occur, it's nullified. So next case. All right, the purple one. Purple one's pretty easy too. You just got to remember to make the denominator equal to 0. So we got minus 3x. What's up top doesn't matter for a very good reason. You can have 0 at the top of a fraction and it's fine. Just can't ever have 0. So we just, whenever there's just one thing, you can think of it all as one big bracket. You just make minus 3x minus 15 is equal to 0. So how do we balance this equation? First we move the 15 to this side. Remember, we can't divide this out until we get rid of the straggler at the wedding. So we get minus 3x is equal to plus 15. Now we can get rid of the, we can get the divorce. And when you divide both sides by minus 3, you're left with, so that's plus 15 by the way, divided by minus 3 becomes minus 5. So x cannot be minus 5. And it makes sense. If we put minus 5 in there and multiply it by minus 3, you get positive 15, and then minus this 15 would make 0. So that's why x cannot be minus 15. Let's look at the next case. These next two you can only do once you solve the factoring. You cannot solve it like this. You cannot make those equal to 0. I mean, you can, but then you still have to factor it. And really it says simplify. Simplify first. So up top you see it has, let's look at the first one. Up top there's a big hint here. We can see a plus 4. So I'm willing to bet down below it's going to factor out to something that's a plus 4. But let's see. What number multiplies out to minus 4 but adds up to 3? Well, there's only two factors for 4. 2 and 2 and 4 and 1. And since it's making a minus, those numbers would be plus 4 and minus 1, because when you add them, they make a positive 3. When you multiply them, they make a minus 4. So right away, those are the factors for this one. So we rewrite it at a plus 4, and then we get on the bottom a minus 1, a plus 4, like I suspected. Before we continue, we find our restrictions. So over here, what would make 0? Well, when a is 1. So a can't be 1. What would make a 0 here? When a is minus 4. So a cannot be minus 4. Now we can simplify. We've got a plus 4 at top and a plus 4 in brackets down below. They divide into each other, creating a 1 and a 1. So we're simplified. We're left with a is equal to 1. Sorry, it's equal to 1 over a minus 1. These restrictions, you notice, if we'd done it at the end, if we'd done the restrictions at the end, we would only come up with a restriction of a can't be 1. But it's not true, because we started with the original formula. So we must also include a cannot equal minus 4. That's the answer to that one. Let's look at this last one. Again, we cannot simplify this until we figure out the factors, and we cannot find the exclusions until we figure out the factors. So we're looking at the top one first. We've got to come up with a number that multiplies out to plus 12 but adds up to minus 7. There's not many factors for 12. There's 12 and 1. There's 6 and 2. There's 4 and 3. And there is, so I think that's it. Do any of them look like they add up to 7? Yeah. We've got to come up with plus 12 and minus 7. So we're talking about minus 3 and minus 4. Those add up to minus 7 and multiply out to plus 4. So right away, we've got our factors at the top. Beautiful. Let's put it. There's going to be a hint up there, by the way, my guess. So we got t minus 4, t minus 3. let's look for the hint. It's probably going to be one of these in the bottom. But there's a secret to the bottom. Let's have a look at it. What's the problem with the bottom, with the denominator? Well, it says there's a t to the 3. I can't do anything with that. And then there's a t to the 2, and there's a t there. Oh my god, they all have a t in them. We can take a t out of them, and we're left with t squared minus 6t plus 9. Now, what are we looking for? We're looking for a number that multiplies out to 9, and that's a 6t, by the way, and adds up to minus 6. Well, 9 only has several factors, 4 factors, 9 and 1, and 3 and 3. So if we look and figure out what number multiplies out to 9 but adds up to minus 3, well, that would be minus 3 and minus 3. They multiply out to plus 9 and add up to minus 6. So right away we figured out the factors. It's minus 3 and minus 3. Oh, that's also called a perfect square. So we just rewrite it as t minus 3, t minus 3. And normally you just write that as t minus 3 squared. But because we have something up top to factor, so I'll get rid of all this stuff and just, this is my new denominator. Because I notice there's a t minus 3 up top, I'm going to keep them separate. But before we do, we come up with restrictions. T cannot be equal to 0, obviously, because of that one. What would make 0 in this brackets? Well, t cannot be equal to 3. And, of course, it's the same for that one. Whenever you get a complicated one in this bracket, let's say you had 5/3 t minus 6. Oh, my God, how do I figure out what that is? Well, you just make the whole thing equal to 0. Well, these guys are all married. They're all multiplying. You'd have to add the 6, so you get 5/3. The 6 goes to the other side and changes its sign. Now, 5/3t. We got to get rid of that 3. So let's multiply by 3 on this side. They get rid of each other, and that's multiplied by 3 on this side. So that's 18. Now we're just left with 5t. We would divide by 5. Divide by 5. This would be the answer, that t cannot equal 18 over 5. And it's complicated, but there you go. So, now that we figured out the restrictions of this one, that t can't be equal to 0 and t can't be equal to -3, we can cancel stuff out. That cancels with that, and they're gone. They both turn into a 1. So we're only left with this, this, and this. So the final answer is t minus 4 and you're just coming in now, and over t and t minus 3. That's the answer. So I'll just post this if you don't get it. It's good to have it anyway.